In this episode of FUM0114 machining, we are going to implant one drill chuck into my lathe. I have found out that I'm doing a lot of peck drilling, and therefore, normally the drill chuck sits in the tailstock, but this lathe has very bad tailstock. It has not a lot of reach, and if I make any hole that is deeper than let's say 40 millimeters, there is already a trouble. So with this one I can do better than that, and to be able to do that we need to replicate one of these. This is for my quick change tool post, and normally the tool would sit somewhere in the side here, and yeah, okay. But there is a thing about cutting forces. In this case, because it's a drill, there will be pushing, and normally with these type of lathe tools you don't get that pushing effect. Therefore the tailstock is used normally. But if I plant it in the middle here, like that, then I will eliminate some of the forces that try to bend this thing. Okay, this drill chuck has alien thread. It's an Imperial thread there. That's the reason why I'm using this. Yes, it's European, it's Röhm, but still it has this very strange Imperial thread. It's 20 threads per inch, half an inch thread. Okay, but my lathe should be capable of doing that. That will be an exercise, and then we will be doing replicating this, including the dovetail. I have a suitable cutter, and yeah. So the first thing is to cut a suitable piece out of my stock for this adapter, and we are going to use my trustworthy hacksaw for this. Okay, let's go on with the cutting process. measuring a dovetail like this. Well, yeah, you could use your quesometer somewhat, but there are some features that you just simply cannot measure with this one, and especially the dovetail itself, because, well, you get measurement here, here, here. It's all over the place. You could probably measure the bottom, but well, that's of no use. So how to, especially when I want to reproduce this one. So luckily there is a very simple method of doing this, and quite accurately. Well, first of all, let's look what are the important surfaces here. How this toolpost, quick toolpost works is that there is a wedge which expands, and then it squeezes using this and that dovetail, expands, and then it squeezes it against the toolpost. Okay, so this means that the working surfaces are like this surface here, and then this backside of here, the edge, that one, not the bottom. The bottom is actually unimportant. It's there just to, yeah, it's unimportant. But for our measurement, this surface is actually really important. So let's start measuring this one. So the first thing is to measure well, the width of this gap. Okay, you could use your quesometer if you only have this type of a measuring tool. So I think the best way is to put it sideways, a little bit sideways like this, and then just pull it across there. And then you read your reading. And in this case it tells me 35 millimeters, this one. But let's do it in a more accurate way. This is an adjustable parallel. Works like this. And then I put this adjustable parallel here in between. It's a little bit tight, this one. I put it in between. There. Squeeze it so that it's tight. Well, it's reasonably tight there. And then I take one Chinese micrometer and start measuring it. This is quite simple. And let's see now what it is this time. This time this is 35.32. So our quesometer gave too little result. Let's see again. Let's do it the other side, like on the back side, if there is a difference there. Because this is a rough edge inside there, there might be some differences. So let's see what this, or how this side tells us, whether it is still like 0.3 millimeters larger. Well, 31, but I think it's safe to say that this is 30.30. Well, 30.30 or whatever, 32 maybe. Okay, I'll mark it there. So it will be 30.32. Okay, that's there. Okay, the next thing to measure is how deep it is, and now you probably will see that there is a recess here. Now you see it. There is a recess here, and then you can actually feel it. There is type of a recess. I don't know why they made this lower, but that one I cannot use as a reference. So what I will do, I have a depth mic here. I will actually measure it from the side here. Let's take this side first, and I push it down quite hard. And there you are. And this one is telling 10.19. I have calibrated this one, so this is at the moment quite accurate. So that was 10.19. And this one is 10.21. 200ths of a millimeter difference there. So let's take a few more measurements here. Let's say it's 10.21. That's at the moment the depth from this near the edge near the dovetail. So 10.21, and then the middle. I want to reproduce this, so I need to measure this one as well. It's 10.47. And now the most important feature here, the dovetail. And you could use this one, but you always have to use pins like this. These are they should be the same size, and they should accommodate in the dovetail like that, something like that. The size doesn't matter by itself, and they even don't need to be the same size. But then you have to use the same pins. And anyway, you place them here in between, and now you can put a parallel here in between. And then you just widen the parallel here, and then you start measuring, and these are tight. Okay. So what we are measuring is the space between the parallel, lost my stick. So the space between these the round things. Okay, so you could use your quesometer here like this, and this one is telling us 21 millimeters, 21.2. Okay, let's see what it is actually. Oh, my pen is still under. And it is 21.70. No, 21.22. So my quesometer gave quite good result actually. 21.22. Let's measure it again just to be sure. Make sure the surfaces are clean. Oh. 22. Well, and here are our measurements for this dovetail. Oh well, now let's put a center line here. I already measured this, should be, well, the center line is not critical. but let's see, this is 78 millimeters, so 39 millimeters is there. Let's see if I can draw a line there, draw another line there. Well, they are not matching, as you can see probably, but that's enough for me. In the milling machine I just put the center in between those lines, and this accuracy is enough for milling the dovetail. Well, now it's quite in the center. So what I did, I used this tool. Well, actually this is my finger. This is the tool. So I used this tool to scribe a line between those lines I made. And now it's in between all the way. And well, of course I dialed in the piece, so shouldn't be there. So now the table is in the correct place. It's locked this way, this way, this way. It's locked. I'm going to use a roughing end mill and going to do my first cut here. Let's see. There might be some wastewater problems. Let me show you. Because we are so near the edge here. So this is it might splash around, and especially from here it might go, so I need to watch that it doesn't go, the coolant doesn't go there. This way here is secured. I just place my splash guard there, and there you go. But that might be a problem. We will see. But if I mill from here to there, maybe not then. The dovetails in this one, and well, I succeeded in overshooting one part already, and this is well, it's actually quite hard to do, but let's see. The thing is that I don't have the DRO, so I need to take backslash in account when moving this back and forth, because I'm I try to make it symmetric. Well, it should be really symmetric, otherwise it doesn't want to bind well. So, well, now what I'm doing here, I'm taking now 2 millimeters more. No, 3 millimeters from here, and then 3 millimeters from that corner. And then I measure it, and then I take the rest. It will, when I overshoot the other one, I messed it up in a way that I didn't measure it in between. I just trusted my dials, and that's the wrong thing to do here, really. So, well, let's go on with cutting. let's measure this one. So originally I used larger pins. I choose a little bit smaller ones for this one because I noticed that those were not very good when you were measuring. At early stages they didn't work at all. So, well, let's see. My goal here is 27.4 millimeters. So I believe, let's take questionnaire first so we know which micrometer to take. It's 26 already. So, so it's very easy to overshoot those. It's really easy. So let's see if we have a good place for that one. Let's move that around, maybe that way. Yeah. Well, it's 26.6. Okay. Well, I half well, I first take half from this side because now it's aligned that way. And then I move back to this side and, well, and then I take the rest out from here. And, yeah, okay. Well, it should be now ready. 27.4 millimeters, let's see. Yeah. Normally I get these really close when I do this, so, okay. Yeah, normally yeah. And this time it's no different. Hopefully you can see that. 27.4 and well, it's inside 1/100th of a millimeter. Yeah, okay. Well, next thing is of course to try this out in the lathe, if it works. Did I finally do it? Let's see. Well, here is one piece and well, it goes there. Wow. Wow, that's not good. Actually, just joking. This was the one I overshoot and this is now the one I made. It's a tad smaller as well. And yeah, and now we are talking. It fits really well. It's an aftermath about this thing. Using pins of this size, well, it was not a good idea. The smaller pins made all the difference when measuring this. You could already measure it in the early phase. And this one, yeah, well, it's about tenths of millimeters. It has to be accurate. And furthermore, the recess here, that was in the original, well, it was not a recess. It was something they had to do in order to do the dovetails. So, what's next? Well, I already did some deburring for this one. Okay. And now this needs to be planted here somehow. Well, there we have one metric. It's alien thread, which is You can actually read it on top of here. It is yeah, it's 20 threads TPI, threads per inch, and half an inch thread, that one. So this has to be done for this end, and here I'm making a little bit larger metric thread for this one. Before I do anything else, I need to clean up this mess. I will first make the M16 fine thread here. It will be 10.5 millimeters then. Okay. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10.5. There you go. And let's lock the carriage here. And there you have. There you have your chamfer. Now it's scraping the bottom of the... So this normally means that the thread is ready. Yeah. There you go. I don't want any oil on my fine file. This is a very, very, very fine file. Just taking away the burr from there. Like that. And then some emery. There is your showroom thread. This is now Imperial threads in a metric lathe. And yes, I have now changed the gears and I have also this is in correct diameter now, 12.7 millimeters. And there is a thread relief which is on the correct diameter. So when the tip touches that one, I already know the thread is there. Okay. There are some peculiarities here. First of all, when I connect the half nuts. After that, I cannot disconnect it. I need to use the switches, and therefore I'm using quite slow speed. Luckily, this one stops quite quickly. Sorry if my hand... Oh, I can take this away here. Wait a minute, where should I put it? There. That's a good place. Oh yeah. Never thought about this. Okay. I made a remote box and let's see now. This is forward. This is reverse. Yeah. Nice. Okay. So I need to use these controls, but luckily this one stops in inside 1/2 turn. No, even faster than that. So I could probably use that kind of speed. Yeah. Okay. So, but when I start, this has it can wreck my lathe, wreck the workpiece and whatever. Okay, now let's start. What should I do first? Okay, now. It looks ready. But it doesn't, the last time I tried it didn't. It's still a little bit tight. Scratch pass maybe. So then might. it this one? No, it's the next one. Yeah, scratch pass. So let's make a scratch pass. Well, it really cleaned up things. Yahoo! It is there! Alien thread! Ready! Oh, wow! This was really fun. So, did I get it right? Well, yes. This piece of tooling is actually very good now. There is this alien versus metric thread. Well, it's a wonder it isn't warmer or there is no nuclear reaction going on. When you place metric and imperial thread so near each other in the same workpiece, there should be some things going on, but yeah, it's cool. Okay, so this one goes there quite easily, and it also goes under the surface, the metric thread. Then this one screws there as intended. Very easily, and when you tighten it, it will be there. That's the workpiece. Yeah, and well, you might think that one thing is missing, and it's the height adjustment. I have been thinking about this, and well, maybe I put it there, maybe I don't. It depends how I feel about this, but I like, in a way, a surface like this, and then, which is, how would I say it, clean. It's easy to keep clean. Anyway, this is now the tool, and well, this is, yeah, it's done. So, in the next episode of Finogric machining, well, what would it be? Well, I know. Let's go through the maintenance of the milling machine. That will be in the next episode of Finogric machining. Till then, see you!